Yeah, so that's why. But today's topic is on what? Friction. I just want to clarify or go through some of the questions on momentum. And I see that I didn't teach belt drives also, which I'm going to do after your test.
You also writing test next week
Yeah.
on site. You must guide me which one. Maybe it's gonna be the moments then. We don't assignments. We don't have to.
Okay, so I think I've introduced momentum. The only thing we didn't do is to go through the, exercise. It was that time I talked about when the object is moving, maybe A is moving that way, and there is maybe a car also moving, car B moving that way. This one has a mass of maybe 10 kilograms, and this object has a mass of maybe 5 kgs. Maybe the velocity of this is 2 meters per second, and this one maybe is moving at 1.5 meters per second. Or we can say maybe 1.8, it depends. We need to know to say the two objects at one time, they need to meet. They need to, either hit. This is when they are going in the same direction. What causes you to hit the car in front? You are moving more than that person, meaning that you have got higher momentum than him. That's the only time you can hit this guy in front. You're going the same way, okay? And I mentioned that momentum deals with the velocity, and it is equals to the mass of the object times the velocity of the object. And we do have two types of momentums I've put there. One is called elastic, and the other one is inelastic. The elastic momentum is the type of momentum whereby after collision, the two objects go the separate ways. You hit your friend, you go backwards, maybe he goes forward, or you go forward, but you don't stick together. You have a different velocity after impact. Momentum talks about the impact, and after impact, what happens? The law of momentum says that the momentum of objects before impact is equals to momentum after impact. But again, it depends with whether elastic or inelastic. Why learning about elastic and inelastic? We want to know when these two objects or two cars hit or collide, are they going to move with the same velocity after impact, or they will go separate ways with different velocities? So if they go separate ways with different velocities, we call elastic momentum, meaning they retain their kinetic energy. Each one of them will go with its own kinetic energy, okay? Then there will be times where after collision, after you hit your friend, you stick together and both of you move at the same velocity after impact. That is where we say inelastic momentum. But the formulas is the same, they are the same. It's mass times velocity. So the law of momentum says that momentum before impact must be equals to momentum after. It's conservation of energy. It's conservation of momentum. So there are two formulas that you're going to be given, or else you have to understand were these two objects moving in the same direction or they were going opposite ways. When a car is coming towards you, you are going the other way. We are going against each other. The signs will be different, meaning that the other one will have minus, the other one will have positive. But in the case of this sketch that I've put down, we are both going in the same direction. So what it means when we are both going in the same direction, the sum of the two momentums for object A and B is addition, okay? You are going to say MVAA plus MBVB. In fact, they use U for initial. Let me use those letters. You remember about velocity? Initial velocity, we use U. So initial velocity, each of these cars had, its own velocity before the impact. So whether one hits the other, in this case, there's no way B can hit A. A is behind. So it means it's only A that must catch up with B and then bump. After bumping, and if we say it's inelastic, it's where they go separate ways and their velocities will be different. So what you do after impact, you write MAVA plus MBVB. Final velocity of A, final velocity of B, which will be totally different. That is what we call inelastic. Then I might as well give you a situation where I say, okay, there's A, and A is going that way, and there's B, and B was going that way. Then the mass of B is MB and VB, or we can say UB before impact. MA, UB, UA, initial. So in this case, we are not going to have a plus there. The B will have negative because it's going against A. You are not going to say momentum of A plus momentum of B. It's momentum of A plus B against. You take the positive as right. Backwards, going to the left as minus. You know about the vectors. Okay. So in this case, we are going to say, okay, it's MA, UA minus M, B, U, B. Then equals to, for you to know what is here, you understand. Every time it is saying elastic, then you have to say what? Each of them will have different velocities. So I'll write the same way. It's MA, VA plus MB, VB, elastic. When we come to inelastic is where the two objects now will go separate ways. Okay, in fact, they stick together. Inelastic is when they stick together. So for inelastic, you write the same way as that, which is MA, UA plus mass of B times initial velocity of B equals to MA, okay, plus MB, the common velocity. Why? Because yes, these two objects after impact, they had to move, stick together for some, reasons. They hook together and they move together at the same speed. Then that is where you're going to use this formula. Either way, even here, after impact, if I say these two objects will move together, then you have to do what? To have it in this form. Yeah. So this will mean that they were going in the same direction. That will mean that they were going in different directions. Clear? That is what we call momentum. And if you remember the Newton's second law of motion, what I mentioned, I gave you 3 Newton's laws of motion. The first one was the object remains in its state of rest or motion unless, unless the force act upon it. Fine, then it will change. The second one was the force and the momentum, linked together. So that's where the momentum is here. The impact or the impulse is the force, will be as a result of what? The momentum. That's what they have got a big relationship. So I'm going to read about momentum and then see, because what the examiner does, he won't give you the formula. The formula will be given, but he'll give you a scenario. You listen to the question first. And maybe this question is like, an object A, which has a mass of 2 kgs, you start making a sketch on your own. An object A, which has a mass of 2 kgs, moves at 3 meters per second. So we have been given 2 kg, and the velocity is what? 3 meters per second. And collides directly with an object B, which has a mass of 4 kgs, and moves at 2 meters per second in the same direction. So it's that sketch. Collides directly with object B with a mass of 4 kgs and moving at 4 meters per second. Fine. calculate the velocity of A if the velocity of B after collision is 2.5. So we know it's elastic because they went separate ways. If they stick together, they'll ask, calculate the common velocity after impact, meaning the velocity of A and B is the same. So in this situation, they give us velocity of B after impact, whether they went, backwards to, or whichever way they went to. B velocity final is given as 2.5. What would be the velocity of A after impact? There is the formula. Being that they are going in the same direction, you just replace the values here and get the VA we are looking for VA. Okay, so I'm going to clean the rest and then just remain with that equation. Mass of A, 2 kgs, times 3 plus mass of B, 4 times initial velocity 4 meters per second equals to the mass of A is 2 kgs, so it's 2 VA. We are looking for the final velocity of A plus 4 kgs times 2.5. Here you manipulate your equation. We have just replaced in the formula and the question is asking for final velocity of A after impact. You are going to cross multiply, get the answer on your left, subtract this answer, divide by 2. That is what you're going to do. 2 times 3 plus 4 times 4 minus 4 times 2.5 divided by 2. That will be the velocity of A after impact or after collision. Done. Then the next scenario they gave us these same things, but calculate the velocity of A if the velocity of B after collision is the same as the velocity of A after collision. You see now. So they want common velocity. Same situation, but if they went with the common velocity, it won't be the same answer. Then we'll have to write a different equation there. Velocity of A after impact is the same as B after impact. Your equation will be MA VA or UA plus MB UB equals to mass of A plus mass of B V, common velocity. You replace the rest, 2 times 3 plus 4 times 4 equals to, what's the kg? 2 plus 4 V. Then you get V. That's their common velocity after impact. So we assume that these are cars, each one with its own weight. For sure, if they are going in the same direction, what you only remember is that this, to catch up with this, must have more momentum to catch up with the other one. Okay, it's going to reach at B and then hit B. If not, B is moving, it depends, but they will meet. If the velocities are going to, they're going to get that impact there. So the common velocity that we are going to get is that one here. How do you do it? To get the answer here, divide by 6. You understand? 2 plus 4 is 6. So it will be 6V. So if you want V, divide 6 into the left side. It's situations like that. Anyway, so in your test, there will be momentum. I'm going to read another question. And you lost there. You want me to finish? What answer are we getting on the left?
60 plus 60.
Here you have 6V. But on the left?
22. 22.
Divide by 6, divide by 6.
3.66
meters per second. SI units are very important in your, If you forget -1, you can't just write a number. What does it mean? That's why there's international units, you see. So I'm going to read this one for you. An object A, which has a mass of 3 kg, okay?
VA is
They're saying, VA is, what's your answer?
VA.
I don't know. I didn't finish. I left it there.
They said it's how many?
Did you calculate?
Where did you get 3?
He's giving me here. But according to the book, that's not the answer.
VA.
No, common velocity, this one.
But-
VA is here, we didn't finish. You give me the answer on your left. I said minus this one.
Minus?
Yes, it will jump to the other side.
Okay.
Then divide by 2.
Is
Right?
what will jump?
Calculate. What's the answer here?
22.
22 minus 4 times 2.5
10.
equals 2 VA. 22 minus 10 is 12. 2 VA. Divide by 2, divide by 2. Yes.
Okay.
That's what I was trying. You know, mathematics, I think this chapter is coming, but I wonder why they put it later. It was supposed to be chapter 1, you know, manipulation of equations, because you need them here. So that's how you manipulate formulas. Yeah. Then we have an object of A which has a mass of 3 kg and moves at 2 meters per second. Let's just change. Mass here is now 3 kilograms, moving at 2 meters per second, collides with an object B which has a mass of 4 kg and moves at 3 meters per second in the opposite direction. You hear that? In the opposite direction. After collision, they move with the common velocity v. Calculate the common velocity. That's what they're saying there. So obviously what will change is the sign. Can you see?
Okay.
Because they are going in opposite direction. But you use the same formula. Using those two figures I've given you, this, that, before. That's all. And then here the sign will change to minus. Do that and give me the answer. Replace MA with 3 kg, UA with 2 meters per second. This is initial, before impact, the velocity was 2. You replace 2 here. Mass is 3, you put on there 3. Mass of B is 4, you put 4 here. The velocity initially 3, say times 3. Then they are looking for common velocity. So it's inelastic.
Nothing. It's negative 3. Or 2, 3.
You can do that.
2, 3.
You know what will change here? What was the mass? You change the mass to 3 kg. The velocity is 2.
2.
This sign changes to minus. Mass of B is 4. Velocity is 3. So here is 3 and 4. Done.
3 plus 4.
Yeah. MA plus MB. You understand? 3 kg plus 4 kg times the velocity. Then you manipulate the way we did and get your V, which is the common velocity. That's what the question was asking. Okay. There's nothing more to this. And where's that part I wanted to talk about? Vertical movement. Potential energy and kinetic energy. I just defined them. I think I didn't explain nicely, but I introduced this part. I introduced that part. Can we move on? Who is lost? Are you fine? You are lost, eh? Where? On this one? Okay. You know what they said? They said that you have 2 objects, A and B, but they're moving in opposite direction. So A is going there, B is going that way, which means that the B, when we write momentum before impact, this is momentum before. This side is after. The formula is like this. It's the mass of one object times the velocity it is having before impact, plus the mass of another object it's going to collide with, times the velocity or it's having before impact. So this they gave us in the question that, okay, object A has a mass of 3 kg moving at 2 meters per second. Object B has a mass of 4 kg moving at 3 meters per second. So what is their total momentum before they collided? You add each momentum separately, but we are not going to add because this is going opposite. This is taken as positive, this is taken as negative. That's why the momentum of B has a minus sign. And when you replace M with 3, UA with 2, this sign will be minus because of the opposite in direction. Then mass of B, 4. Velocity of B, 3. You multiply the 2. Equals to, after impact, they are saying these two are stuck together and moved with a common velocity V. Calculate V. To calculate V, you add the masses together, which is 3 plus 4 times common velocity. You don't say VA or VB, it's common. It's just V. Then we get the answer. What's the answer on the left?
-6.
-6 equals to, what's the answer here? 7. What's V? Divide by 7, divide by 7. What's your answer? -0 point something.
857.
857 meters per second. That's the speed. Okay. So when you get your answer like this, it means that it's going to move more to the negative direction. You know, when they stick together. The minus is just telling you that the impact is more to the left. So after they stuck together, they didn't go to the right. They went to the side of B. B had more power than A. And B was having a minus. And that's why your answer is minus. It's like, which direction did these two move? Right or left? So if you get a positive velocity, it means they move to the right. Yeah. Obviously, one of the two will be powerful than the other for them to move together. Yeah. Okay. Then, because we are talking about kinetic energy here, what happens when they stick together? They go with the same kinetic energy. What is kinetic energy? Kinetic energy is the energy that an object possesses due to its movement or due to its motion. When your car is in motion, it's got kinetic energy. The way you are sitting there, you possess potential energy. Potential energy is the energy an object possesses due to the state of rest. You are not in motion. But immediately you are walking or the way I'm moving around, I've got kinetic energy. But you're sitting, you possess potential energy. So these two energies, you know, they relate. What they say is the gain in kinetic energy equals to the loss in potential energy. Just in case they ask you to state the law of energy. The law of energy in the other way, we say that energy cannot be destroyed nor created, but can be changed from one form to the other. You can't destroy energy, and then you can't form energy, but you can change from electrical energy to, you know, chemical energy to mechanical energy. The same way you can change kinetic energy to potential energy, or potential energy to kinetic energy. When I say potential energy equals to kinetic energy, they balance. Then it means that the law of energy is what? Conserved. Yes.
What about a black hole?
Pardon?
A black hole.
Mhm.
That sucks up mass, doesn't it? Don't consider anything.
No.
Still consider anything, because once you go past off the event around the mountain, you get back out. There's no law that can explain what happens in a vehicle.
Yeah.
So once we get that, we'll explain what happens.
Maybe try to research about it. You are thinking nice. That's why you are an engineer. Maybe think that way and invent something. I think he's thinking, he's thinking, you know, out of the box. All right, so that's what on that law of conservation of energy is all about. But when we come to the formula, kinetic energy is equals to half mass times v squared. As long as you know it's kinetic energy, you must remember velocity is involved. Why? Because we are talking about energy possessed due to motion. Okay, that is this one. And then when we come to potential energy, it's mgh. There's no velocity there. What is there? It's the mass, gravitational force, and the height. It means that energy, which we call potential energy, is to do with the elevation or height. There will be times examiner wants the potential energy here and the potential energy here. Which one has more potential energy, on the ground or up? Yes. Why? That's all. The height. The more the number you have here, you know, the greater the height, the more the potential energy. And when we come to kinetic energy, the speed. If you want to have more kinetic energy, you need more velocity. Because obviously you see v squared. So when we come to potential energy, it is low here. And they say that if you have an object on the roof, it has got high potential energy due to the virtue of the height. Okay. So where do we use this? They'll tell you, they'll give you a scenario, you know, where they want you to calculate. Yeah, I've got this question now. A body with a mass of 5 kgs, okay? A body with, okay, before I go there. When we say potential energy is low here, what happens to kinetic energy here? Ke is what? High. And here, Ke is low. What makes Ke low here is because the velocity here is 0. Here it will come with a certain velocity. Velocity at this height there is 0. V is equals to 0. So before I go there, I wanted you to understand that kinetic energy is more at the bottom than on top, but potential energy, that's what I said, the loss equals to the gain. You see here, we are saying loss in potential energy is gain in kinetic energy. Up here is gain in potential energy, loss in kinetic energy. It's a law of energy. So this question is saying a body with a mass of 5 kgs falls freely from rest. Falls freely. And then with a velocity of how much? 12 meters per second. Just before it touches the ground. This 12 meters is not the velocity started with. Before touching the ground, the word is there. A body with a mass of 5 kgs falls freely from rest and reaches a velocity on the ground of 12 meters per second. Calculate its potential energy while it is still at rest. While it is still at rest. While it is up here at rest. So while it's at rest, it means that you have 0 velocity up there. What happens to the kinetic energy? 0. Which formula can I use? Obviously, they didn't give the height. For you to calculate this, you need to have the height. They have just given us the mass and the velocity. Do you remember the formula for displacement? You must use it. You cannot get the height and you cannot get PE without the height. This question is asking for potential energy while it's still at rest before it could fall down. But were you given H? No. What is H? It's S, which is displacement. Which formulas of displacement do we use when we are given the 2 velocities, 0 and 12? You get my point. Initially, it had 0 velocity. It fell with 12 velocity. Which formula for displacement are we using? I gave you all the formulas of motion.
Well, it takes from the high to low, to how many meters it is.
There's a formula that we use.
S is equals.
That's why it's a vertical. If it's S, give me that one.
S is equals to initial V over time or something.
Okay.
The displacement.
There is S equals to UT plus half A. This is not going to be A, it's G, half AT. This is not going to be used because we don't have time out. We can use V squared, U squared, plus 2GS. You remember, it was 2AS when I was teaching linear velocity. When we come to the vertical motion, acceleration becomes gravitational acceleration. So on every formula where you get A, as long as they are saying it's vertical movement, you replace with gravity. And that's what I've done there. I can't use this one. I know it's displacement formula, but I don't have the time it took. But I can use this one because I have a final velocity of 12 and I have 0. I can get its S. And only once I get the S, I can go and put the S here and get the what? Correct. Okay. Final velocity is 12 meters. 12 squared equals U squared is 0. Plus 2 times 9,8. Are we using 8, 1 or 8? I don't know. In the book. Times S. I think it's 8, eh? You must know which one they use. Hey? What science? No. Check nicely. Gravitational acceleration.
So is it still 9.8?
I'm
Oh,
asking.
still 10.
Others use 10. They use it 10 now. And that's why I'm asking you, check in the textbook. If they use 10, we are going to use 10. So please, before anything, we check if they're using 10, 9,8 in this book.
So
Back
the
home, I
example
was using 9.
Explain it.
It's still alright, 9.8 or 9.81. In Zambia, we used to 9.81, but it's fine. It's not 10 because I see they are using 9.8. If it's 10, I think they will tell you in the instructions there. I know their instructions. They will tell you use gravitational force of 10 or 9.8. So how do you get S there? Can you show me how to manipulate this equation? What's the answer? 12 squared here? Yeah, we'll go to subtract. Not even to subtract, you divide. Why? Because of the times here. The only way is to divide, not time, not minus. What answer are you getting here?
144.
144 equals to, what is this times that?
It's 19.6.
19.6 S.
Yes.
Yeah. Then to get S, you divide them.
Yes.
19.6 and here 19.6. So displacement equals to 7.meters. That's the height. The question didn't ask for height, but what? Potential energy. And then I can't save until I put this there. So you can now get your potential energy. The mass was how much? They gave us the mass of this object. Where was it? 5 kgs. 5 times 9,8 times 7.34. You get your PE in joules.
359.66.
359.
0.66.
Because it's energy. So you must remember the SI units also for energy. That was the first question. Okay? Although they asked for the height later on, but you can't get potential energy before the height. You only get the height and then potential energy. Yeah. So if ever they ask for kinetic energy, I think you can get, right? By using 12. Because kinetic energy is low down there. Okay. Then we can do this one, which is the last one in vertical motion, and go practice. A body with a mass of 6 kgs is projected vertically upwards. Now this is from down going up. At a velocity of 8 meters per second. It means that it started with high velocity, but up there will be 0. Don't forget that. That's why they say it was projected with a velocity. There it was, before reaching down, it got a velocity. How much is this velocity given? 8 meters per second, but it's not coming down, but it's starting going up that way. And this object was here, projected up. It's now 8 meters per second. Calculate the maximum height that it will reach. Same things, eh? I don't think you fail because they want the maximum height. It's using this equation here. No time involved, so you can't go to this one. Only if they want the time. Yes, they must give me the displacement. And the rest I have. Okay, so calculate the maximum height. Then calculate the kinetic energy when it is 2 meters above the ground. 2 meters above the ground, they want its kinetic energy when it's somewhere here. 2 meters above the ground. What do you do when it's 2 meters above the ground? Was the velocity the same? No. So you must solve. So we need a sketch. I'm going to clean and just see. When you come, let's say it went all the way to here, and they want the height. To get the height, I've given you the formula which says v squared equals to u squared plus 2gs. This one is 8, okay? Because they said it started, this one will be 0. This one will be 8. You see the difference now? Yes, 0 when it reaches there. But it's not 0 somewhere here. No, 0 when it goes to the top, like rest.
Yeah.
Okay. Plus 2 times 9,8 s. Then you get s. 8 will move this side, it's going to be negative. 8 equals
Wait, we're
square.
not squaring them.
You square it.
Yeah.
And then what's the answer there? 9,8 times 2.
Nineteen point six.
19.6 s divided by 19 divided by 19.6. Okay. Then what's that distance? Mm-mm.
Three point two six.
2.6.
Yeah.
But the question is when it was at 2 meters here, I think that is the tricky part. When it's at 2 meters here, what is kinetic energy? How to get the kinetic energy when it is there, which is half mass v squared. You must know what is the velocity here at 2 meters. To get that velocity, you can also use that equation, or, I think that's the only equation, right? Because the s is given. So in short, I'll just replace that because that is what we're looking for. What is the v squared? Is here. Initially it started with how much? 8. So v squared equals to 8 squared plus 2 times 9, what's this? 8, eh? Times distance 2 meters. Get the velocity first, and then you come and replace it there. There's no way you can get kinetic energy before you get the V. So what is our V? And then once I get that, then I replace in the formula, then I know that, at that point, kinetic energy is so much. What is V?
103.2.
And
103.2.
did you square? You remember there's a square here now. That one we did in math, square root the answer. To get rid of that, right? You square everything on your right to get rid of this. Eh? Someone is lost here, please. Where are you lost? They want kinetic energy when the object is at 2 meters above the ground. Not when it reached up here. Obviously, when it reached up here, the kinetic energy will be 0 because of the 0 velocity up there. So at 2 meters, we calculate first its velocity. I want that. Then it's half times the mass of 5 kg, or 6 times the velocity. What's B? Okay, 47.2 meters per second. Then we come and replace here 47.2 squared, right? Because it's half mass V squared for kinetic energy. Then you get you.
141.6.
141.6 kinetic energy. Yeah, this is a very important topic. I think you need to practice, regularly, go through and understanding what happens to, velocity up and down. And then what is the final, what is the initial? You need to know. They will never say that it started with a final velocity from down coming. No, it reaches with a final velocity because velocity up here is 0. When you're throwing up, it starts with a velocity and reaches with 0 at that point. Yes.
Will you ever get terminal velocity?
What's that?
Terminal velocity.
Of what? The object?
Yes.
No, not terminal. They just give you the initial before it was raised up.
But if it's high enough, won't you reach terminal velocity bar when it's down there?
No. No. Okay, so on this part, they also want, I think that's all, velocity at 2 meters. Then you can go to page 23 in your time, spare time, and go through all these activities that are here. I want to move on to this friction. This is vertical motion. Now it's friction I must introduce. Very important. 12 marks in the exam just for that, if not 15. And for those that did last year with me this, we did a lot of questions on friction. So it means your test is going to cover until friction, everything. From statics, dynamics, when I said dynamics is acceleration, velocity, displacement, until this part here. You know what is friction. In engineering, friction has got advantages and disadvantages. It depends where you need it. Like when I come to a clutch, I don't think a clutch can work without friction. That's why they call frictional clutch. Because on the flywheel and the plates, there must be high friction. If the plate is finished or the disc is finished, then it's not going to perform. It won't be efficient. We need friction on the rods between our tires and the road. If there's no friction, the car won't move. It will just be in one position. There are advantages there where we need friction and disadvantages. Yes. The what?
If you're going too high on the friction on your wheel, it slows down.
Yeah, it will slow down the power. We need that track. They call it traction, traction, friction, which helps, to push the car forward. Yes, there is engine power forward. There's also traction power trying to resist the engine power. But in doing so, it's helping the car to move forward. All right. And there are other places where we don't need friction. Where is that bearings? The bearings are supposed to be, though they call anti-frictional bearings, they call them anti-friction. They must always be smooth and, with oil. Fine. They are not called frictional bearings. No, they are anti-friction. Okay. Why? Because they are holding a shaft that must be always be lubricated. So in friction, we are going to talk about horizontal friction when the object is sitting on the plane and maybe it's pushed to there. This is force of acceleration. Do you know that the friction force will always go against? we represent that friction force like that. There's a relationship between this one and that one, okay? If these two are equal, is the object going to move? No. It means it's in equilibrium. Yes, if this is more than that, will the car move to the right? No. You see, for this car to move, obviously accelerating force must be greater than friction force. And the formula for force is mass times acceleration. And I've already mentioned that acceleration is the change in velocity over time. The mass must be in kilograms. Then when the object is at rest, just remember, when the object is at rest, it's got the mass in kgs, and then the weight is always acting. Do you know? The weight of the object will always act towards gravity. And the weight of an object is its mass times its gravitational acceleration in newtons. Then there's a reason why this object is not sinking down. Even in the way you're sitting on the chair, why are you not sinking down? To every action, there's equal and opposite reaction. Okay? When we come to the boat and the sea, what's this? The pontoons and everything on the sea there. Yeah. The weight of the boat itself is being held by buoyancy force. You know, you've heard about the buoyancy force from the water. That's why the boat is not sinking, because it's being held. The weight of the boat and the weight coming down is the same. So it remains there. Once the boat is overloaded and all that, it exceeds the reaction, then the boat is sinking. So every object, there is the Newton's third law of motion, which states that to every action there is equal and opposite. So this weight of the object is equal to the normal force. They call this one the normal force. It's equal to the weight of the object, and it's acting in the same line but in the opposite direction. So if ever they ask you for a normal force, just use mg, but acting opposite to mg. Then we do have situations where the object is sitting at a slope. They'll give you the angle here of the slope. And now they say that this object is resting here. It's resting exactly there. Do you know that its weight is still going down? The gravitational weight does not change. It's always going to be vertical. So from the center of the box, you need a vertical line going down. But where is the normal force? The normal force is not going to go that way. The normal force will still be that side, going up. Then we need to resolve this. You remember last week we did the resolving. To resolve the weight of the object, to bring it in that direction. And to resolve that weight, you have to say its opposite. There's a theta here. This theta that you see here, okay, is the theta here. They call it the angle of repose. The angle of repose is the angle that keeps the object on the slope stable. Immediately you just push it or you go against that angle, it starts moving. So the repose angle is a very important angle. It keeps the object stationed, but should you push the object, a little bit, it's going to change. It's going to either move down or move up. So under friction, there are two situations you are going to encounter, can be in the exam or anyway. It can either be the upward movement, or it can be the downward movement. So if I use this as upward movement, I'm telling you that the acceleration is going that way. Can you see? I'm pulling that box up. Where is the friction? down. Friction will always be parallel to the plane. So our plane is that line there. So it means that the friction force is the force coming opposite to the accelerating force. And that's the friction. Then what is this one here? Do you see when you resolve here, there's a force here and there's a force down? We talked about this. Which one is this, cos or sine? Is sine. Can you see? Why? Because it's opposite over hypotenuse. So this horizontal force, let me just remove this. This weight is coming down, it's mg. Then this one is mg, or the weight times sine theta, and it will always be acting in this direction. It does not change. What makes it act in that direction is the fact that the weight is down, the arrow is down. It's what we did on the forces last week when I was resolving those triangles. So the vertical force is going down, which is the mg, which is your weight. But the component, we call it the horizontal component to this force, is W sine theta. And it will always act downwards. It will never go up, regardless of which motion is going up or down. That remains down. Then the vertical component of this, weight is W cos theta. Can you see? And it's acting in that direction. So now, the question will be, calculate the acceleration force or calculate the friction force. They'll ask, or calculate the mass in many things, but I'll come to that. The other thing I want you to know is the relationship between this and that. There's a big relationship between the friction force and that. I don't know if you've heard of coefficient of friction. Coefficient of friction is a ratio of friction versus what? The weight. It's written like that sign, mu. They call it mu symbol. Is equals to friction force over the normal force, either normal force or mg. If I say force normal, it's this one. But again, the normal force is mg. Don't get confused. In our situation there, the normal force is there going that way. But it is equals to W cos theta in the opposite direction. When it's sitting like this, it's just mg. There it won't be mg. There it will be mg cos theta. Why mg? Because this W will be replaced with mg. Okay, now I'll go to another drawing, which is for upward, downward. You're going to have a sketch with a slope and a theta there, and they'll give you a box there. This, they're saying the force is acting down, which is your accelerating force. Where is your friction? Backwards. Then this one is mg, down. Then there is what? Normal force. And mg, or weight, cos theta, downwards. This one, W sine theta. Normal force up. You see the sketch. The sketch won't be given to you in the exam. Examiner will give you a, theory question. The object is sitting at an angle of 12 degrees. Blah, blah, blah. There's a horizontal force or accelerating force parallel to the plane. They will give you. The secret is, remember this formula. Remember that formula. And the displacement, S. You know why S is important. I'll tell you that it is displaced from here to here. You need to know what is the displacement, which is V squared, U squared, and UTS. You know those two formulas for displacement. If they give me time, I can calculate the displacement. They can also ask you to calculate potential energy of the object. What do you need to know? Height. Height of a triangle. Can you see? We'll come to the cos what, as long as you have this and you have your displacement. The displacement won't be in this line. No, it will be in the plane. The difference between the two sketches is that here the friction force is going up and here the friction force is going down. So I'm going to clean and give you the formulas that you are going to forever use if they tell you that it's moving up or it's moving down. And that formula is the one that I said is the law of forces. Do you recall the law of forces upwards and downwards and the law of forces horizontal direction, right or left? You must use that one. And how does that one look like? You're going to say sum of horizontal forces. Then you start looking at your sketch. Which are the forces in the horizontal direction? Going to the left, okay, sum of forces horizontal to the left equals to sum of forces horizontal to the right. You remember this one? Looking at the sketch, your horizontal plane we are acting is this one. That's your plane. Which are the forces to the left? Is this one? Is this one? Can you see the arrows? To the left or the of this Y line, of this center line here, or it's this one and that one. For you to know left or right, you stand like this. This is right hand side, this is left hand side. So forces on the left is these two in the horizontal plane. You add them together. You are going to say friction force plus W sine theta, because they are going in the same direction, equals to force going up, accelerating force, MA. Fine. Then you need to look for upward forces. Upward forces is sum of forces up equals to sum of forces down. Which one is your upward force? The normal force, which is W cos theta. You agree with me? Yes. The normal force is the same as W cos theta. It's equals to W cos theta. So you are going to say upward force. This one is downward force. This one is upward force. So this one, you can say the normal force equals to downward force, which is W cos theta. You can write it that way. It means the same. Any other downward forces? No. Being that you are doing, some of you are doing N3, you know the situation they'll give you. That friction or accelerating force, I want you to focus here. This accelerating force cannot be given this next time. They'll give you at that angle there. And they give you maybe 15 degrees. And they say accelerating force. Can you see what I've done? That is on N3. N2, mostly they don't advance it that way. Then once they give you that force acting like that, you must also resolve it. Bring it in the horizontal and the vertical plane. So meaning that this won't be like that anymore. How is it going to be? It's going to be acting here and there will be a vertical force down that way. This will be the angle there 15. Let me just say alpha. I'll use that sign, alpha. So opposite, it's FA sine that. You agree? It's the opposite side of that alpha. Then the horizontal here will be FA cos alpha. I've changed the question. What does it mean? This won't be FA anymore. Your right hand side force, and it's not even right. Can you see there? It's left. It's 0, so we don't have right. Do we have right hand side? Unless I said it was a pulling force. If we want, this arrow, if I say it's going upwards, it must be going up like that. Then this will be going where? Up. This will be going to the right. Check the sketch, because this is under upward force. So this right hand side force will be FA cos. Can you see? When we come here, it won't be this. It will be W cos theta. Where is it going? Downwards. Upwards, we are going to take FA. It's N plus FA sine alpha. You see what I've done here? Those are the ones going up. And then later on, they'll ask for, maybe FA is not given to you. The examiner will be calculate FA. Then to calculate FA, you can either use the sum of horizontal forces or the sum of vertical forces, or both. So I'm going to read one question, and then from there we can, because we are shooting. I'll just read one question. Don't forget this relationship here. Because this relationship here, under normal force, I can put, check here. If I'm looking for normal force, do you know that normal force is equals to friction force divided by mu? Manipulation of equation. The mu most of the time given, which is a number less than 0, 0.2, 0.3, it's a relationship between those two. So it will always be given, and then wherever there is normal force in your calculation, you can replace it with that. That's what they're saying. Let's read one question. Friction. Okay. The first question says, it's a horizontal plane. I'll start there. A pulling force, P, which makes an angle of 30 degrees with the horizontal plane. A pulling force, P, there is a horizontal plane. There is a box. Okay? And there is a pulling force, which makes an angle of 30 degrees. This is P, pulling force to the horizontal plane. Is moving a body with a weight of 400 newtons. This one. The weight is 400 newtons. Over a horizontal plane at a constant speed. Calculate the size of force P when the coefficient of friction is 0.3. Coefficient of friction is 0.3. They want you to find P. Which formula? Which formula are you going to use? Upward equals to downward force. You see? That one. Why? Because this is a downward force given to me. Then if this one is going up, you can resolve it as P. This one will be going that side. It is P cos 30, P sine 30 degrees. That's what you're going to do. So the question is, what is P? And if you are going to substitute and using, upward equals to downward, you need two formulas. One for the horizontal plane and the other one for the vertical plane. So if you use the one for the vertical plane, already you can see this equals to that, going up. That is on upward forces. So for those with a textbook, if you look on page 125, they're saying reaction, which is your normal force, as we are saying normal force, going up. You can't ignore that force. Page 125, Science and 3. Reaction force, friction force, they have shown that is here. You understand, because this thing is going that side. So your friction force is going that side. And they put friction force as mu times normal force. Yes or no? You know why they replaced this? Because we've said mu is equals to friction force divided by normal force. You remember?
Yes.
So if I'm looking for that, it's like this, ne? This is friction, which is this times that. That's what they wrote. It's the same. Though they are using R, it's the same as the friction force. So you're going to say perpendicular forces. Forces going up equals to forces going down. How many forces are going up? Yes. You add, eh? It's this. You're applying this formula, guys. Upward equals to downward. So when I look at the sketch, the upward forces is which one? This one. Normal force plus, P sine 30. Downward forces, yes. Then the question is asking for P. Do we have normal force? Yes.
Okay.
What is your normal force? Normal force, because we said the normal force is equals to mg. Again, we said that.
Yes.
Correct. So your normal force, or which is your reaction, will be 400 minus. You are going to make an equation here because they really want you to put it in equilibrium. That 400, or you can take that 400 minus P sine 30. Is that right, what we have written there? When I say normal force equals to the weight, it is when it's in equilibrium. Okay, when it's in equilibrium. But here, you have to find the normal force, which is also not given to you there. They gave us coefficient of friction, but the normal force was not given, and this was not given. There are two things that are not given. And that's why there's going to be one equation, that is your first equation, that you have to substitute in the plane, which is the horizontal plane. I'll go to the horizontal plane, you'll see now. Which one is the horizontal plane? There. For horizontal forces to the left equals to forces to the right. You look at that sketch. Which one is left? You see, friction. So I'll put friction on the left. And anything? No. Equals to which one are going to the right? Okay. P equals 30. But do you know that friction can be replaced with that? You see?
Yes.
Because this is given, the mu is given, but Fn is not given. We want these two formulas to have Fn. So that Fn will come and sit on Fn. Okay? So what I'll do, I'm going to replace that friction with mu times Fn. Okay? Mu times Fn equals to P cos 30. But we know mu is how much? Yes, so I'll just replace this with 0.3. Can you see equation 1 and equation 2? There's no way you'll be able to solve a topic of friction before you can do the horizontal and the vertical forces. We make an equation on the horizontal and on the vertical, and then we come and substitute. So I can take equation 1, or let's say equation 2, or equation 1, whichever, and substitute Fn. You see here there's Fn, and here there's Fn, and here there's Fn. They mean the same. So it's a matter of taking this one and go and put on Fn. But that Fn will mean that you are working with what we call substitution method. So that you remain with only P, which they are asking for in the question. Is it making sense?
Yes.
Okay. I'm going to replace, don't forget this formula. Let me leave it down. I'll replace in here. Let's write 0.3 times, you open your brackets. What am I going to put in the brackets? That. Because it's the Fn. You are going to put 400 minus P sine 30, close brackets. What comes? Equals, equals to P cos 30. At that stage, you can get P. You see, there's only one unknown, which is P. And this continues with whether it's that or that, we are going to be working with vertical and horizontal and then fuse them together to get what they're asking. Here you just manipulate. You say this times that, this times that. Give me the answers. Expand, remove the brackets. On the left, 120. Or for this part, of 120 minus sin 30 times 0.3.
One point five.
0.15 P. And here cos 30 is what?
0.86.
What do we do? You move the P to the right. Okay? You remain with 120 equals to 0.86 P plus 0.15 P. Add the P's. What's the answer? Here on your right, what's your answer?
It's 1.01.
1.01 P divided by 1.01 here and 1.01 here. That's your P. P equals to 120 divided by 1.01. Because this one will cancel out.
That's 118.1.
118.1 newtons. That's that force there. That's that force there. So I'm going to do one last example on the incline, because this one was at the incline, but same situation. We will deal with horizontal and vertical components and then fuse them together. And then, yeah, you must be able to get it right. Let's go to, yeah. A mass with a weight of 600 newtons. A mass with a weight of 600 newtons. I'll use one of those sketches there, but just put the figures. 600 newtons, so mg is given, right? A mass with a weight of 600 newtons. I'll come to here and put 600 here. The weight is already calculated. Then I'll put 600 here. And I'll put 600 here. Can you see what I'm doing there? It was W cos theta, W because the weight is given. Calculate the smallest. Okay, rest on a plane as shown in the figure. I will do the sketch nicely. There's a pulling force. That one I've put there with 12 degrees here. They have given 12 degrees there, and this force is going out. 12 degrees. Okay, so cos 12 sine what? 12. And this force doesn't have, it's just F. I'll just say F for pulling force. Then the friction is going down. They didn't give us. Calculate the smallest force needed to pull the mass up the incline of 15 degrees. This is 15 degrees given. So this is sine 15 and cos 15. Because that was 15. You see, that's the sketch. What are they looking for? They are looking for that force that needs to pull the object up. F. I'll clean and then we do the horizontal and vertical forces on here. So this is upward force because they showed the sketch. And then some other examples, they will just ask you to just draw your own sketch and then do the calculations. Under horizontal components, what is our formula? Let's look at the sketch. Which are the horizontal forces going to the left? Friction, okay. Then,
600 sine 15.
yes, this one. Plus 600 sine 15. Done, eh? On your right hand side, remember there's nothing here. This thing was the initial sketch. On the right is FA cos, you can say FA or just F, yeah. FA cos 12 degrees to the right. Done. Is there anything? We are only having three forces, 1, 2, 3. Then I'll go to the upward forces here and then change the formula. Which are the forces going up in the sketch? Normal force, okay. So you say F normal and then plus FA sine 12. Forces down,
600 plus.
that's only. We don't have a number. There are only three.
Plus, isn't it?
Oh, this one. We are not going to use 600 sine. Sorry. It's 600 cos 15. You can't use 600 because it's not perpendicular to the plane. That's why we are resolving to bring it perpendicular to the plane. So it's 600 cos 15. And then I want you to replace your normal force with, you remember that formula I said friction or mu equals to friction force over normal force. So your normal force is equals to friction force over mu. You know that, eh? You must know this formula. So they gave us the coefficient of friction. I didn't finish reading. If the coefficient of friction is 0.2, which is it's given. What we want is to eliminate the Fn. The Fn, because you won't just guess to say Fn equals to, no, you have to prove that to be in balance, the Fn needs to be so much. So in any case, we have everything except that we are looking for this one. We can even put it in red. The question is asking for Fa, which is this one here. Let's replace. Friction force is not given. We don't have the friction force, but you can represent the friction force in terms of what? Fn. How is the friction force? It's this times that, can you see? Friction force equals to Fn times mu. I'm going to replace that friction force with Fn times mu. Okay? You are going to say Fn and mu. Mu is given, so it's 0.2. I've replaced mu with 0.2. That's the question. Fine. Plus 600, what's the answer here? Just give me the answer here. Sine 50. Come again? Okay. Equals to, what's cos 12? Cos 12 degrees.
0.97.
Fa. Equation 1. Okay? Then we go here and make equation 2. Fn. What do I? Fn, you just leave it as Fn because here there's Fn. You understand? We want to have Fn and Fn on both. So Fn equals to, I'm going to take this to the right hand side, making Fn the subject of the formula. I think you saw that's how it happened the other one. Fn equals to 600 cos 15 minus Fa sine 12. Are we together there?
579 is wrong.
That's wrong,
Yeah, the textbook is wrong as well.
The textbook is wrong. Is the textbook giving 579? No, you punch. Me, I'm just following.
155.
Here,
Yes.
when you say 600 sine that,
Yes.
it's 1?
55.2.
Okay. That's the 600 cos 15. Then equation 1 is formed. Then equation 2 is making Fn the subject of the formula. Then you can reduce here. What's the answer here? 600 cos 15.
Where did you get that 155? It's 579. 600 sine.
15. Make it.
Oh, yeah.
It's fine.
They took cos.
Yeah, they
Yeah.
used cost.
The one that was there, supposed to be there, down there,
Mm.
600. Cause, man,
Okay.
because for the scene was.
Are you sure?
Because it seems like they already swapped it. They already.
For sine is fine.
Wait. Go back to page 126. I think it's us who swapped the signs. Look at the angle of the slope. The sign should be this one. Can you see? The theta must be sitting here, in that corner. The book is not wrong.
Yeah.
It's this angle that's wrong here. It shouldn't be this angle. It should be the angle in the corner here, which makes this one sine and makes this one cosine. Check in the textbook. The angle which is making it's this one. So every time you use the one in the corner, not the one with the vertical plane. Big error. Big error. It's good we have seen it now. Please, the angle they use is this corner here. You see? Not in the inside there. They use that one there. Then once you use that angle, this is your opposite, which becomes what? Sine theta. And this becomes your cos. And many times, the cos is a horizontal plane. I think we know from trigonometry. The horizontal plane is always your cos. Why? Because it's rare that they use this angle. We always work with that angle. So if it's like that, is this one going to be sine, cos? Yeah, it's fine. And then here, sine. You only change those signs. What else? What's the answer now here? Okay, 579.55. What else to change? Is this one cos or sine?
That sin 12 should be 0.2.
Yeah. We are here.
That one, yes, that's sin 12, that one's a 0.
On here.
Yes,
It should be.
0.20.
Who gave me this number? It's 0.20. Okay, and then I want to fix here before we calculate. Only remembering that don't use that angle that sits up here. Immediately you use that, this becomes sine, that becomes cos, and it messes the rest of the things up. But always remember with the triangle sitting this way, that anything in the horizontal direction is cos, and anything vertical, which is this side here, is your sine. I think you won't be lost on it.
So we calculate our angles from the resting plane.
Correct. You
All
follow
the
the
time.
all the
Using
time.
the angles.
Correct. You always follow the parallel. You see the rod is here. So this is your horizontal plane. And every time that one should be your cos 15. This will always be your sine. And if this is a sine, it is also opposite to the normal. Yes, it's just those things that you need to know. So if we do that, that equation is fine here. Now I'm here where we say F sine 12. This is correct. Can you see there? Why sine 12? Because they're using the angle at the horizontal corner. It's correct there. Then equals to 600 what? Cos 15. That's fine. Downward force is sine. We have changed. Remember the downward force is this one. It's this sign. Yeah. So now I am going to take this Fn and replace here. But what's the answer for 600 cos 15? Is this cos 15? Where did I take this from? Oh, it's that one. Sine. Then you subtract Fs sine 12. Check that equation I've put for upward force. I will find there.
155.29.
But is it first written correctly according to what we have on the sketch? It's wrong. No, how is it wrong?
It's correct.
I don't want the answers. The sketch is confusing. How? Look here. This is your downward force, friction force. When we come up here, the force was a pulling force, right? Good. And then what is the horizontal component of this triangle? This is 12 degrees. Opposite to, that is what? Sine. So it's FA sine, then the horizontal plane is FA cos. We are fine there. When we come to the normal sketch, I've just changed now to say the theta should be in here, in this corner, not there. So if the theta is here, opposite to theta is the side, which is 600 mg sine 15. Because this and that are the same.
So maybe is that 600 sine 13, since it's parallel to F mu sine 12, isn't it the same value?
It's
Because
parallel
it's just
to what?
parallel to that one at the top.
This one.
Yes, to
And
that one.
to this one.
Yes.
This one is going up because of the
Oh,
pulling
okay.
force. This is going down. So I can't add the two. You can't add them because one is going up, one is going down. And when you look here, we said all upward forces, and which was this one, and then Fn. This is Fn, which is this one. Must be equals to downward, which is this one, sine 15. There is sine 15. As long as here we are clear, then we can go and replace. Otherwise, I can't replace if you are not understanding what's happening there. If it's wrong here, the way we did using the theta, which was in the corner, then it messed everything up. You can't use 15 degrees up, but at the corner, like that. Can I replace? And I was asking, what is the answer here? Or everything, what you get here first? 600 sine 15.
It was 155.29.
0.29. Then minus FA, what is sine 12? Hmm?
It's 0.20.
20. FA. You know what to do? This is equation 2. You are going to take equation 2 and replace it with, check. Equation 2, you lift everything and go and put on Fn. And then solve PFA, I mean FA.
There's somebody supposed to pass this.
Yes. How many?
We can't minus. This is test FG.
It's got FA, you can't. It's got FA, you can't. You cannot minus these two
Yeah.
because this one has FA. So you're going to now replace, which I'm going to do in this box here. It's 12, 15 marks, guys.
Too much.
I know it's too much, but
5 marks or something.
no. 25?
Give us pass.
No.
So, but how do we prove it?
To balance.
Because at the end, you might calculate, you see, we made tiny mistakes.
You know, listen how to prove. How we are going to prove when I get the answer of P, all right? And then I'm going to calculate Fn. Because once we get P, I don't know, I'll come back to prove, I'll show you. Yeah, I'll come and prove either here or here. Let's get Fa first. We'll prove. Fa, you're going to write 0.2, open brackets, you put what is Fn, which is 150, 5.29 minus 0.20 Fa. Can you see? I've replaced Fn with what it means there in equation 2. Then I continue plus 579.55, okay, equals to 0.20 Fa, right? Check. Here you expand or divide. I don't know which is easier. Divide by 0.2 throughout. It means divide by 0.2, divide by 0.2, divide by 0.2, so that you get rid of that 0.2. Then the brackets are out. Okay? Then I write 155.29 minus 0.20 Fa plus, what's the answer? This one divided by that. Eh?
Isn't it? going to the bracket.
No, that's another way. You can expand or divide throughout by this number. Either way, it's the same. If you want, you can open up the brackets that way. Or divide by 2 throughout.
That's a big number.
It's a big number, it's like thousands.
It's fine, just give me, it's still right.
2897
289
7.75.
equals to FA. Can you see there? Because 0.2 divided by 0.2.
It's
It's FA.
20.
Which one is 20?
0.20.
It's the same.
Okay, let's see.
It's 1. 0.20 over 0.2. It's the same. Even there is no 0. It's 1.
Okay. Yeah.
Can we go on now? We have to put the FA together.
Yeah.
You can see the FA is alone there on the right. Take this one with FA there and remain with numbers on the left.
Okay.
The numbers are 155.29 plus 2897.75 equals to FA plus 0.20 FA. You add your right, you add your left. What is on the left?
We must divide.
You add these two.
That's 3,000.
Just give me 3,
3053.04.
0.04 equals to, on your right, it's 1 plus that. It's 1 point something, 1.20 FA. Divide by 1.20. Divide by 1.20. What is FA?
Where did they get 1.20?
This is 1 plus that. There's a 1 there. FA plus 0.2. Is it not 1.2?
Okay.
Gosia.
That should do something. That's good.
You pass your N4 if you get this. And this strength of materials, I did this diploma, BTech, you find these calculations. It's the basic, but once you understand it, you can go to any university and do your degree there. This one, I don't know. You are lost. I can see.